Today we're going to solve quadratic equations using the quadratic formula again. This time what we're going to find is we have imaginary roots. And that will happen when the discriminant, which is the piece under the radical, b squared minus 4ac, is less than 0. So let's do this for practice. Recall what the quadratic formula is above now. In order to use the quadratic formula, it needs to be set equal to 0. So the first thing I'm going to do on this first problem is subtract the 6x. From there, I can see my a value is 1, the number in front of x squared, b is negative 6, and c is 12. Using the quadratic formula will be negative b, which is 6, plus or minus the square root of b squared, which is 36, minus 4ac, so 4 times 1 times 12, all over 2 times 1. So we'll have 6 plus or minus the square root. And if you take 36 minus 4 times 1 times 12 in your calculator, you get negative 12. So that's 6 plus or minus the square root of, and the square root of negative 12. Well, the negative will come out as an I. And that radical 12 will simplify to 2I radical 3. Finally, look to see if anything goes into 6, 2, and 2, and 2 does. Final answer will be 3 plus or minus I radical 3. And that's it there. Let's do some more for practice. This one's already set equal to 0, so I can say A is 1, B is negative 4, and C is 8. So plugging into the formula, it's going to be x equals negative b, which is 4, plus or minus the square root of 16, minus 4, a is 1, c is 8, all over 2 times 1. So x equals 4, plus or minus the square root. 16 minus 4 times 1 times 8 is negative 16. So we'll have x equals, the square root of negative 16 is 4i. Over 2. Finally, we see if something goes into 4, 4, and 2, and it does. 2 does. And final answer, we will have, let me write it right over here, x equals 2 plus or minus 2i. Let's practice again with this one over here on the right-hand side. What I'm going to do is set it equal to 0 to solve. So I'm going to subtract the 4x and add the 7. Now I'll go straight to plugging into the formula. So it's going to be negative b, which is 4, plus or minus the square root of b squared, which is 16, minus 4, a is 1, c is 7, all over 2 times a, which is a 2. So we'll have 4 plus or minus the square root. And if you do 16 minus 4 times 1 times 7, you get negative 12. And which is the same as we had above. So we already know that that simplifies to 2i radical 3. Finally, we look to see if something goes into 4, 2, and 2, and it does. 2 does. Final answer is going to be 2 plus or minus I radical 3. That's the main idea of today. Now, this next piece below says find the values of c such that the equation will have imaginary roots. We know, and I talked a little bit about the discriminant already, but the discriminant is the piece under the radical. And if that piece is negative or less than 0, then the equation will have imaginary roots. So what I'm going to do is say that the discriminant, or b squared minus 4ac, has to be negative or less than 0. Now let's plug in. b squared is 9, a is 2, and I'm solving for c. Well, this is 9 minus 8c, has to be less than 0. To solve for c, I'm going to add the 8c, so I'll have 9 has to be less than 8c. Divide by 8. So we're going to get C has to be greater than 9/8 in order to get imaginary roots. Let's try the one on the right hand side. It's the same idea. B squared minus 4AC has to be less than 0. So B squared is 16. A is 1. C has to be less than 0. 16 minus 4C is less than 0. Add 4C. And then divide by 4 to solve for C. We get C has to be greater than 4. So as long as you pick a C value greater than 4, the equation will have imaginary roots. At this point, what I would like you to do is to try the 3 do now problems.